is a fuzzy control system like this. We can take a fuzzy PD control system like this and consider the closed loop system where this is the Planck model, and this part we call it a fuzzy PD control, where we use two informations. One is the error signal, the other one is the derivative of the error signal. And then we need to perform fuzzification to get the fuzzy set for these two signals. And based on this fuzzy set, we can perform fuzzy inference to get the output, which is a fuzzy set variable. And then we should get the exact control signal by defuzzification process. So this is the fuzzy system, fuzzy controller in real fuzzy PD control. So this is the structure. And to implement a fuzzy PD structure, what we need to do, because there are three fuzzy variables, so we need three set membership functions like this. And here you just use a simple triangular membership functions. And for these three variables, for each variable, I used 8 fuzzy sets for them. One is negative, but the absolute value of it is very big. And negative, medium, negative, small. Just to talk about the absolute value, not the real value. Negative big, negative medium, negative small, or negative but approaches to zero with our fuzzy sets here. And also we have another 4 fuzzy sets. One is positive, that approaches near to zero. And the other one is positive small, positive medium, and positive big. So we can use this fuzzy set to describe the fuzzy signals. And this is one thing. The other thing is the fuzzy inference system. I would say that for all the 3 fuzzy signals, we can describe the fuzzy membership functions and fuzzy sets like this. We have, for each of the variables, we have to define a fuzzy sets for it, and also the membership function sets. And then another important thing is, what should the fuzzy inference like? For fuzzy inference, if you check existing papers, you will find that there could be a fuzzy inference table like this. You can get the results from the existing literature. And this one is really created based on real control experience. If the error is negative and big, and also if the derivative of the error is negative big, then we have to set U to negative big. I think you may read this kind of fuzzy inference table later on yourself. I think this one is comes from existing paper, so it should be. I didn't write the citations for it, but it should be correct in real applications. And you may find this kind of tables in different literature. But the fuzzy tables might be slightly different, but fortunately they should be similar. And with the use of a fuzzy inference table like this, we can create the fuzzy inference system, and then we can perform fuzzification, defuzzification using simulating blocks. Now I will explain how to realize this kind of problems in Matlab. Suppose there is a Planck model like this, and here there is an uncertain element A, where A could be between 5 and 50. There could be a large variations with variable A. So it could be very difficult to design a controller for this kind of plant. So how can we solve this kind of problems with the use of fuzzy PD controller? We have to take the following procedures. The first is how can we establish fuzzy sets for the three variables? And then how can we express the fuzzy inference table? And then how to create a simulate block diagram for the fuzzy logic control system. And then we can simulate the system and see the results. So let's do it from the very beginning. To create a fuzzy table, to create a fuzzy set, we should give a command like this, fuzzy. And then you will have a graphical user interface. This is the prototype of the fuzzy inference system where we have input signal, the fuzzy inference system, and the output signal. Now let's go back to the fuzzy PD control problem. In fuzzy PD problems, we have two inputs and one output. However, in this block diagram, we have only one input. So we have to modify this block diagram in this way. We have to use edit, and there is another command, add input, because we need two inputs. So we can click this button. Now we have two inputs and one output. Okay, so now let's express individually each of the input and output signals. And we can see that the range of the signal input 1 is between 0 and 1. And we can change the range of the input according to our own needs. For instance, you can change it from -1 to 1, something like this. I cannot change it due to the So let's double click the input signal. We suppose this one is signal E. We can rename it to E. And this one we can rename to ED. And this one we can rename it to U, just for simplicity. So we can rename the variables. And then let's go into the into the E signal. If we double click it, we will have an interface like this. And in the interface, we have to modify the range of the equal signal because we have to use negative big and positive big. So we have to use, for instance, -2 or -2 to 2 or other ranges. So we can modify the range for this signal. Also, let's go back to the inference system. We see that for each of the variables or each of the signals, we have 8 sets. However, in this